And we're back. Woo! So I haven't, same day, so I haven't done the, you can see my shirt. So I haven't done that Acron video VR yet, and or I haven't tried playing it yet. That'll be this Saturday. That'll be tomorrow. Woo! I'm excited. So let you know how that goes next week. Ask me about it. So then we're going to just continue on with this homework assignment. So how to graph these by hand, right? How to graph these by hand. So don't forget that the negative means to go upside down. So can we graph this regular and then flip it upside down? Looks like we're still doing the fourth power, so that's a good thing. We have the parent function for that. Do you remember the parent function for that? So we did our parent function up here, which was x equals 4y. And so we have the coordinates, So we have the coordinates from this parent function of a log base 4. And that parent function again was 1/4. Right? We had it up here. Watch the other video if you haven't seen how I got it. So 1/4, -1, 1, 0, and 4, 1. And then we plugged in a fourth. And what did we get again? The fourth was, -1. Again, what are logs used for? Why are these even useful? So in our previous lesson, we learned that logs actually solve for exponents. And if you're looking at your compound interest formula, that's the t, that's time. So logarithms help you solve for time. How long does it take to increase or to decay the amount of money that you earn in a savings account or you lost in your car depreciation? So logs are really, really, really important. They also convert our 10-base counting system to a 2-base counting system for computers, zeros and ones, making this video even possible. Thanks, logs. Okay, so then we're going to show you kind of the shifting here now that we're doing base 4 still. And so the original parent function here, we'll do with the dashed line, was 1, 0 over 4 up 1, and then over 1/4 down 1. And so this was the parent function. And so we're going to go in and shift that now and flip it upside down. You ready? Here we go. So we're going to go in and shift it what? What does +3 inside the parentheses mean? Remember, it's opposite. So it's going to be left 3. So this point will go 1, 2, 3 at -2. We have a dot there. The vertical asymptote will now be shifting left 3 as well. So that's going to go 1, 2, 3. Okay, awesome. And then this point also over 4 up 1, which was from our parent function. So over 4 up 1 was our parent function there. That's also going to go left, 1, 2, 3. Cool. So this function would go up and to the right, like that. But the problem is there's a negative. So we have to flip it upside down. So that means this point actually goes down here, right? And so this point stays the same. This point goes down here. And then this original here, which is going to be a 4th and down 1, is going to come up here. And so our graph is now upside down, and this point went upside down. And so here's our actual answer. Graphing it by hand and upside down. That was crazy. And so what was our asymptote again? Our asymptote is at not 0, it's at, we shifted left 3. So it should be at -3 is what our asymptote looks like. Maybe it looks better if I do it like this for you guys at home. Cool, so there's a longer asymptote there. And so our asymptote is at x equals -3. Our domain is from -3 to the right forever to infinity. And then our range is -infinity, +infinity. Because it goes up forever and down forever. Up forever and down forever. So it goes up forever and down forever. Again, the domain starts here at -3. This is almost -3. This is like, I don't know, -2.999 is what we do there. Yeah, to infinity. So that's why we say parentheses with the -3. Okay, let's try natural log. Woo! So ln, the opposite of ln is e. So we're going to turn it into an exponential and then use y values to find the x values. Whoa, Nooble's back. Just put these two videos together. So basically, I was struggling with, I'm going to try a different way. I was struggling with number 15. And so I tried to graph it, and that was absolutely wrong. So we're going to try a different method. And yeah, I tried to switch the, I tried to solve for x and plug in just like I did before, but it did not work very well. So we're going to try again. And this time I think we'll just do the parent function, and then we'll just do the shifting, because that did not work. So let's just go to the parent function. And so the parent function for number 15 is just y equals ln of x. And then we're going to shift it up 2, and we're going to shift it left 3, and that'll be a lot easier. Okay, so how do we do this? Well, we got to solve. We got to solve for, I just switched the ln of x and the y around, and I want to solve for x now. And then we can plug in using the xy table. So basically, ln, what we learned here is from our book, is that they're opposites of each other, right? They undo each other, basically. And so let's go over here. Let's change a base. This is not what we're looking for there. Yeah, opposites of each other. So I think that's right about here. Yeah, so basically natural log is the same as ln of x. And so they also undo each other. And what I mean by that is if you have like ln of x, I don't know, equals 5 or something, and you're trying to solve for x, you're going to go ahead and undo the ln by shoving a base underneath it. And so by shoving a base underneath it, that gets rid of ln. And I'll show you an example there. So an example could be, let's take a look there. So I don't know, let's come up with something for x. Let's say x is, I don't know, 10. So we're going to go ahead and do like ln of 10. So I'm going to shove an e underneath it, second e, and then do ln of 10. And or even do 12, because that's a different number. So the whole point of this is to show you that e undoes ln. Right? E undoes ln. Those cancel out, and you're left with a 12. So e undoes ln. Cool. So e undoes ln. Awesome. So those cancel each other out. Why am I teaching you that? Because now I'm going to go ahead and do that. So I'm going to base e both sides like that. Awesome. So then I get x is equal to e to the y power. And now I'm going to do an xy table. But this time I'm going to choose values for y and not x. So let's see here. Let's go and do our standard -1, 0, and 1. And so now x equals e to the -1 power, e to the 0 power, and e to the 1 power. And so e to the 1 power is equals just 2.71828. Right? Do you remember that? 2.71828. E to the 0 power is just a 1, so that's over 1 up 0. E to the -1 is 1 over e, which is basically 1 over 2.71828. And so just to kind of go off those coordinates there, let's see here. So let's write those again. So when we plugged in a -1, we got 1 over e, which is 1 over 2.71828. And that's a -1. We plugged in e to the 0 power, which is just a 1, 0. And then we did 2.71828, and then that's just 1. So we're going to go over 2.781828 up 1. And then we're going to go, let's see here, we're going to go, let's see, a fraction. What is that as a fraction? So 1 over 2.7 is like nearly a third. So we're going to basically go over just a little over a third, and then we're going to go down 1. So here's our graph. Looks like most logarithms, doesn't it? Looks like most logarithms, except for maybe this key feature here, which is actually over e up 1. And then this one is your starting that you're used to. That's over 1 up 0. And now we're going to shift it up 2 and left 3. So let's go ahead and shift this 1, 0. So we're going to go left 3. So 1, 2, 3, and then up 2. Good. So what's left of that is an asymptote. And so our asymptote is also going to go ahead and shift left 3. 1, whoopsie. Our asymptote is also going to shift left 3. So 1, 2, 3. Good. And then don't forget this other coordinate over here. It's also going to shift left 3. So it's going to be 1, 2, 3, and up 2. And then this one as well is going to go 1, 2, 3, up 2. And so there's our graph, up and to the right, up and to the right. There's our graph, up and to the right. And so this new starting point, it was 1, 0. But now our new starting point is going to be left 3. And so that went 1, 2, 3, and negative 2. And then up 2. Yep, so that basically 1, 0 became negative 2, 2 for our starting points. Cool. So we have an asymptote at 1, 2, negative 3. So we have a vertical asymptote at negative 3, which means our domain then is negative 3 to infinity. And then our range is negative infinity to positive infinity. There we go. Let's double check our work and see. So I'm going to go to graph this, ln of x plus 3 in parentheses. So that's the ln button. And then we go x plus 3. And then we go plus 2. And there's our graph, right? It's hard to see. So it does cross there at a y-intercept of 3.09. But right about here, it is going to continue down. It's just hard to see. If you push zoom in, then you'll see that it carries on downward. See? It keeps on going downward. Keeps on going downward. It gets really close to negative 3. Okay, so that was definitely a toughie. Had to go back and do that one. So the inverse function of exponential, what's the inverse? Pause me, try it on your own. What's the inverse function of an exponential function? Are you listening to my video? Because you better turn up the volume. For 16 and 18. Because I'm going to say it out loud, but I'm not going to write it down, so you better be listening. So the inverse function of exponential is a logarithm. The base of a common logarithmic function is base 10, right? Base 10 because we count on 10 fingers. So it's going to be base 10. The logarithmic function for ln of x, so the log function ln of x, is called a natural function. Whoa, natural function. Cool. Okay, so next we're going to show you how to write a logarithmic equation in exponential form. And so really we should have taught you this first because that's how I learned to graph. Sorry about that. Okay, so maybe I'll reverse teaching it next year. So basically you take the base and you make an e for exponential. So you take the base, so base 7 to the negative 2 power equals 1 over 49. So we do base 7 to the negative 2 power equals 1 over 49. And that is a true statement. And that's our answer. That's a true statement, you guys. Because if you plug it into your calculator, that's a true statement. So if you plug it into your calculator, if it lets me. So if you plug it into your calculator, second quit, clear. So first of all, 7 to the negative 2 power is that decimal, which math fraction is 1 over 49. So that's a true statement. But what also is a true statement is the log base. So if you do log base of 1 divided by 49 of negative, so base 7, sorry. Let me open the door because some people are coming from flex right now. So log base 7 of 1 divided by 49 is negative 2. It's a true statement. Sorry about that. So it is a true statement. Let's do a quick video. So it's a true statement. So that's awesome. So try it again. So ln of 8 is 2.0794. And so basically we want to rewrite that as an exponential. And so we're going to basically, we're going to base e both sides because that undoes the ln. And now we're left with e to the 2.0794 is equal to 8. And so that's our answer, right? And so try doing that. So it's basically like log basing 16 to both sides. Oh yeah, so this is basically basing 7 to both sides. And that's how we get 7 to the negative 2 equals 1 over 49. Write the equation back in logarithmic form. And so now we're going to log both sides basically. And I'll probably show you that in our next video, because this plus the other problem is a little bit longer. So keep on watching. See you in the next video. Bye for now. No, Newbold, one more. Okay, fine. One more. So how do we do this guy? So basically 81 to the 1/4 power equals 3. And so we're going to log base 81 both sides. It's how we turn it into a logarithm. And so we're going to log base 81, gets rid of base 81, and if you do it to one side, you have to do it to the other side. And so now we have our answer, which is log base 81 of 3 is equal to 1/4. And that's our answer, turning that exponential into a logarithm. This one we're going to ln both sides. Ln both sides, that gets rid of base e. So now we're left with 4 is equal to ln of 54.5981. And so then we're going to kind of turn that around. And so that's our natural logarithm. And if you plug that in your calculator, you'll get that as an answer for 4. So thanks for watching there. And so then we also can use our calculator. And I'll just show you some more stuff on our next video, our last video. So thanks for watching. Bye for now.